Please welcome Blue Lamb, software engineer, Windows and the device group, who will discuss designing and optimizing for long battery life and responsive Windows devices. Let's welcome Blue.
Hi everyone, my name is Blue Lan. I'm a software engineer on partner engineering team. I'm excited to be here with you to share our battery life and performance plan for Windows 10 Fall Creators Update. We'll be reviewing OS features, tools, and test kit that enable our awesome partners to design, develop, and ship responsive Windows devices that deliver all-day battery life to your customers. So let's briefly go through the agenda. We'll start with the perf and power slider user experience, which put the user in control of making the trade-off between power and performance. And there were several improvements we are making around charging and discharging, power plant user experiences. And next, we're going to talk about how software-defined batteries extend battery life on devices that ship with 2 or more batteries. And there were also several updates to share on the plan of record for disconnected standby and adaptive hibernate user experiences, as well as the latest list of modern standby scenarios that are supported in the Fall Creators Update. We have also made several improvements that were made into the system report. Then we'll dive into some updates on hardware-based power measurement solutions that work well with energy estimation engine. And we'll close with some new media quality energy and energy efficiency workloads that have been added into ADK. So we introduced the perf and power slider user experience in the Windows Creators Update as an OEM opt-in feature. And this feature improves battery life by 10% when the slider is in the recommended or power saver positions. This feature gives user more control of making the trade-off between performance and power. If you click on the battery icon in the taskbar on the device that has this feature enabled, you will see the slider in the battery fly out. It is visible on both AC and DC when the selected power plant is balanced, or any custom power plant that is derived from the balanced power plant. To learn more about the initial release of this feature, please check out this Windows 10 Creators Update blog post. So let's take a closer look at the 4 power performance and power slider positions. The battery saver delivers the best battery life, is displayed on DC only, and is automatically enabled when the remaining battery capacity is 20%. Battery saver throttles Windows features, such as Windows updates, and reduces the screen brightness by 30% to reduce power consumption. This is the best settings for users that know they won't have access to their AC power. To learn more about how battery life works behind the scene, please visit this URL. Recommended is the default out-of-box position that delivers long battery life than the default settings on the previous OS releases. Recommended is available on both AC and DC, and this is where we expect most users to land most of the time. Better performance slightly favors performance over battery life and would be appropriate for user who wants to trade off power for better performance. This setting is displayed on both AC and DC. Best performance favors performance over power and is targeted at user who wants to trade off power for performance and responsiveness. In the Creators Update, the performance and power slider user experience was an OEM opt-in feature. In the Fall Creators Update build, we are enabling the slider user experience out of box on most of the Windows devices that have batteries. At first, we are enabling the slider on the last 4 generations of Intel chipset, but our plan is to expand the support to all processors. The default slider position is OEM configurable, and the sliders will appear on devices that are upgraded to this build. In the Creators update, if a user changed the slider position on DC to recommended, the setting will remain the same after the user plugs into AC. In the Fall Creators update, the user settings will stick on AC and DC. In other words, user can set the slider positions on DC to recommended and better performance on AC, and the OS will remember those values as the user transitions from AC to DC. Power throttling is a feature that we experimented in the Creators update, and we are enabling in the Fall update. This feature throttles the CPU frequency of the application running in the background, improving battery life. A common question that we often get from our customer is, what impact does the slider have on gaming mode? These features operate independently of one another, and game mode can be engaged in all 4 slider positions. So let's review the 3 perf and power knobs that are engaged behind the scene by the perf and power slider. The first knob is the battery saver, which was introduced in Windows 10 and saves power by throttling Windows components such as Windows updates and reduces screenness by 30%. The second knob is the processor power management optimization, which allows the OS to make performance or power trade-offs in the CPU. In the Creators update, this must be enabled by each OEM. So please reach out to your silicon vendors for guidance on how to enable and customize PPM settings through Windows provisioning. In the Fall Creators update, the OS will ship with default out-of-box PPM settings that will be available on battery-powered devices from several chipsets. The third knob is the power throttling. Most people have multiple things running at the same time, and often what's running in the background consumes significant power. In the Fall Creators update, we leverage modern silicon capabilities to run background work in an energy-efficient manner, thereby enhancing battery life significantly. With power throttling, when background work is running, Windows places the CPU in its most efficient operating modes. Work gets done, but the minimal possible power is spent on that work. So let's take a closer look at each perf or power knobs that engage by the perf and power sliders. The first one, all the 3 knobs are applicable to DC power. However, only PPM optimizations are enabled on AC power. Second, the user can configure a few battery saver related settings, such as whether or not reduce screen brightness. They can also configure which apps are power throttled. However, users do not have the ability to modify the PPM settings. Third, the OEMs can only configure the PPM settings, and Microsoft recommends you to either use the default settings or those provided by your silicon vendor. Fourth, all these 3 knobs are available out of the box in Fall Creators update. However, power throttling in early Fall Creators update builds is only supported on Intel 6+ generation processors with speed shift technology. The plan is to expand the support to other processors in future Windows releases. Fifth, the battery saver does not have any hardware dependencies. However, as noted earlier, both PPM tuning and power throttling currently have hardware dependency. So let's review which power or perf knobs are engaged or enabled on various slider positions when the device is on AC power. The key takeaway here is, first, all the 3 perf or power knobs are enabled when the slider is on battery saver position. Second, the PPM and power throttling is enabled on both the recommended and better performance slider position. Third, only the PPM optimizations are enabled in the best performance slider position. Now let's review which perf or power knobs are engaged or on various slider positions when the device is on AC power. The key takeaway here is the battery life, battery saver, and power throttling are not applicable to any slider positions on AC power. However, PPM optimizations apply to all three slider positions. OEM cannot opt out apps from being power throttles. However, users have two options to do this. The first option is to opt specific apps out of being power throttles in the battery user experience by unchecking the two checkboxes shown in the screenshot. The second is to simply move the power or perf or power slider to best performance, which disable power throttling for all applications running in the background. We are also adding an API for app developers to define what level of power throttling the OS applies to them. Details will be posted to MSDN by RTM. So in this section, we are going to review several improvements we are making around charging, discharging, and power plant user experiences. So that's before we begin, let's review a few definitions of AC chargers. A normal charger is the one that is designed for the device and is in good working condition. A weak or slow charger is one that may not be designed for the device and delivers a slow charge when plugged in. An incompatible charger is one that is not designed for the device and does not provide any charge when plugged in. So let's consider this scenario. A user purchases a smartphone and a laptop that both support USB-C charging. Although the charger provided with the smartphone does not meet the requirement for charging the laptop, user may accidentally use them charging their laptops, which result in a slow charging experience. In the fall creators update, if you have a device that supports USB-C charging and Windows detect the machine is charging slowly, a notification appears that reads, "Slow USB charge connected. To speed up charging or prevent discharging, use the recommended charger and cable for your device and make sure it's directly plugged in." If the user clicks on the battery icon, the battery flagout directs them to a website where they can learn more about common causes of slow charging. When the user's fall creators update device is plugged into an AC charger and it reaches critical batteries, Windows pops a dialog warning the user that the device is discharging even when plugged into AC power. This reduces the chance of losing work and also provides the user time to find a normal AC charger that is designed for the device. This user experience is applicable to all types of AC chargers, including USB-C. When a user inserts a USB-C charger that is incompatible with the device and provides no charge, the Windows pops a notification to inform the user that PC is not charging, use the recommended charger and cable, and make sure it's directly plugged in. Click on the battery icon opens the battery flagout, which displays the message, "Unsupported charger," along with a link to learn more. In the fall creators update, as you can see from the screenshot here, we are removing power saver and high performance power plants from UWP and legacy Win32 control panel. Only the balanced power plan and other plans that are derived from balance will appear in the control panel. The legacy power plans will remain configurable via APIs, Power CFG, and Windows provisioning. If an OEM creates a custom power plan that is derived from high performance or power saver, those will not appear in the user experience. Software-defined batteries applies to devices that have 2 or more batteries. OEMs can leverage the software-defined batteries APIs to improve the battery life by 15 or more %. Software-defined battery, which is a built-in OS component, it learns from the user behavior and sends the hint to batteries to charge or discharge from battery A or B. The battery driver makes the final decision on whether to charge or discharge battery A or B. This feature adds value because the OS knows when and how our users use their machine, and battery firmware does not have access to this information. So let's consider this software-defined battery use case. Jack has a device with 2 batteries, one in the top, one in the bottom. The OS learns that Jack typically detaches the keyboard after 6 p.m. So starting at 3 p.m., the OS sends hints down to the battery firmware to discharge from the keyboard in order to preserve the top batteries. In the morning, the OS may suggest discharging from the top batteries in order to age the batteries at a similar rate. If you are interested in learning more about how software-defined batteries can extend battery life on your device, we encourage you to reach out to your Microsoft contact to get access to the software-defined battery simulator tools, API spec, and white papers. So in this section, we'll review updates in the disconnected standby and adaptive hibernate user experiences, as well as the latest list of modern standby scenarios that are supported in the fall Creators Update. Before we dive into details, let's review standby and hibernate terminology. When you close the lid and press the power button on your Windows device, it transitions into one of 2 low power states: legacy standby or modern standby. Legacy standby, also known as S3, is the standby power model that Windows have supported for over 25 years. Modern standby is an umbrella name for connected and disconnected standby. Modern standby also offers wake usages and background scenarios that are not available on legacy S3. Modern standby also support the instant-on experience and enable OEMs to comply with new regulatory requirements that will be enforced over the next several years. Disconnected standby supports several modern local wake sources and offers limited network connectivity. Connected standby offers the same capability of disconnected standby plus additional scenarios that require connectivity. Hibernate is a deeper sleep state which has a lower power floor but higher resume latency than S3 and modern standby. These are several triggers that will transition a device from standby to hibernate. In the power and sleep user experience, there's a user configurable option called network connection that reads, when my PC is asleep and on battery power, disconnect from the network. In the Creators Update build, there are 3 options. First is never, second, always, third, when lid is closed. This setting provides user control of when to drop the network or switch from connected standby to disconnected standby. The power floor is typically low when the network is disconnected because there are few activators. In the fall Creators Update, an option called Managed by Windows has been added, and the when lid is closed option was removed. The default setting is never and has not been changed in the fall Creators Update. Let's review the definition of Managed by Windows option. When the lid is closed, Windows takes an inventory of all the UWP apps that are running. If an app is important and recently used, the OS will connect it to network. Important apps include voice over Internet Protocol apps and all apps that users set to allow to run background tasks in the battery user experience. So let's review adaptive Hibernate updates. There are several reasons why Windows devices will transition into Hibernate, also referred to as S4. For example, the DOS to S4 timer is an OEM and user configurable static timeout value that will send an S3 or modern standby device into Hibernate. In Windows 10 version 16.07, we introduced adaptive Hibernate for modern standby devices. And adaptive Hibernate provides 3 triggers that will transition a device from modern standby to Hibernate. There are 3 triggers. The first is user prediction. The second is the standby budget. The third is active usage reserve time. The user prediction trigger is designed to send the machine into Hibernate when the user does not typically use their device. This trigger has been removed from the Fall Creators update along with the Save Me power when my device knows I'm away setting in the power and sleep user experience. The standby budget triggers adds up all the battery drains in a 24-hour period and sends the machine into Hibernate if the drain exceeds 20%. This trigger remains unchanged in the Fall Creators update. The active usage reserve time trigger will transition a device from modern standby into Hibernate when the remaining battery capacity level reaches the point when there's a 30 minutes of active usage left. This trigger remains unchanged in the Fall Creators update. All 3 adaptive Hibernate triggers are OEM configurable. Please refer to the appendix of this presentation for additional information to disable these Hibernate triggers when testing and optimizing the modern standby power floor. So let's switch gear and review a few of many scenarios and usage models that modern standby platforms offers over legacy S3. Let's start with Wake on Voice. The scenarios enables a Windows device to wake from modern standby using a hardware keyword spotter that is always listening for a keyword, "Hey Cortana." In this example, the user asks their modern standby device, "Hey Cortana, will it rain today?" The device quickly wakes and resumes from disconnected or connected standby and passes the command or question over to Cortana, who responds with the answer. Additional hardware is required to enable this scenario, including a hardware DSP and mic array that support far-field audio. Users can also wake their modern standby devices from disconnected or connected standby by simply touching the fingerprint reader. One touch of the fingerprint reader wakes the device and passes the credential to Windows, logging the user in one quick swipe. Bluetooth devices such as Fitbit Watch can sync in the background while a device is in disconnected or connected standby. When a marathon runner or a weekend warrior returns from a run and is within Bluetooth range of their modern standby device, the state on their watch will automatically sync with their UWP Fitbit app in Windows and save user time. Connected standby devices can save user time and make them more productive as Windows device does the busy work of checking for downloading and installing updates while in connected standby. This functionality is limited on DC and on meter connections. Continuing listen to your favorite music with longer battery life when in modern standby. Any UWP app that streams or plays music locally will continue to play in the low power audio mode after the device enters disconnected or connected standby device. Earlier in the talk, I mentioned that disconnected standby offers limited network connectivity. The screen-off audio playback scenario is the main except to that rules where always completely disconnect from the network when in disconnected standby. Similar to the phone experience, when the Windows device is in connected standby, incoming UWP Skype calls or instant message will wake the device and notify the user. This functionality brings the PC experience one step closer to the phone user experience. Users of connected standby device does not have to wait for their email to sync after resuming from standby. The UWP email, calendar, and people apps sync in the background when the device has access to Wi-Fi or a meter connection. In the Fall Creators update, we are adding support for third-party UWP apps to register with the Windows notification server, which enables them to wake a connected standby device on incoming network notifications. Apps such as Facebook or Ring Doorbell could wake and notify user on their connected standby device. The next two slides are references that list out the supported modern standby scenarios in the Fall Creators update. We are not going to walk through each of the scenarios in this discussion, but I encourage you to review these slides, which are a preview of what will be posted on MSDN at RTM. This table is a reference of the scenarios that can wake and turn a modern standby device screen on. We reviewed a few of these scenarios earlier in the presentation. This table lists out the productivity and enterprise scenarios that are supported in the Fall Creators update. So then let's switch gear and talk about power debugging tools. System Power Report is an inbox utility that reports power state during modern standby and active user sessions. To collect a system power report, launch an elevated command, then runs power CFG/SPR. The SPR replaced the power CFG sleep study in the Windows 10 Creators update. This report contains E3 energy data for each active and modern standby session. The system power report also prints out the top offenders that activate the device during modern standby sessions, preventing the machines from remaining in the deepest runtime idle platform state or DRIPS. Windows goes through several different phases before entering DRIPS. So let's review what's some of the improvements that we have made into System Power Report in the Fall Creators update. Components that block entering the desktop activity moderator and maintenance phase will be printed out. In this example, culprit.exe is preventing the device from entering the desktop activity moderator phase of modern standby. Occasionally, System Power Report report abnormal change rate that are used by high variation in the full charge capacity at modern standby entry or exit. In the Fall Creators update, System Power Report print out the full charge capacity at modern standby entry and exit to help identify these cases. In the Windows 10 Creators update, the System Power Report provides high-level information around why the modern standby session ended. In the Fall Creators update, we improved the report by offering a higher level of detail. In the example shown in this slide, you'll notice the System Power Report display user input as the reason modern standby sessions ended in the Windows 10 Creators update. However, in the full Creators update, the system power report displays specific modern standby exit reasons such as keyboard, mouse, power buttons, and touchpad. This functionality provides engineers with more debug information. The system power report reports application that keeps the GPU active and block the machine from entering drips. In addition to printing out the active time, System Power Report also provides the additional metadata on GDI updates and wakes that facilitates optimizing the modern standby power floor. So, what is E3? E3 is an inbox service running on all battery-powered Windows 10 devices. E3 attributes energy usage data by hardware, applications, and services. The software estimation accuracy of the CPU power model on recent Intel chipset is around 89%. The software estimation accuracy of storage, display, and network is less than 70% accurate. The actual accuracy varies depending on how different the hardware power characteristics are from the device Microsoft used to generate the default power profiles. The hardware measurement accuracy on all four power models is 98% accurate. Microsoft highly recommends utilizing hardware power meters on pre-production devices as they are low-cost and scalable solutions that is compatible with E3. There are hardware power meters produced by Microchip and Maxim that offers 98% accuracy in power monitoring. Microchip has solutions in development and sampling to customers under NDA. Microchip has an in-market solutions as well as chip that is in development. I encourage you to reach out to these IHVs to review the spec, ordering samples, and request for additional information. So let's compare the various power instrumented solutions that are available to partners for debugging and optimizing for power. Fully instrumented devices typically monitor 32 to 64 rails, have low component flexibility, are not compatible with E3, and do not scale due to their high cost. The Intel HDK falls in between the costly low-scale fully instrumented device and the low-cost individual power meter chips. The Intel HDK has a high component flexibility, is compatible with E3, has a medium scale, and can monitor 32 rails. Individual power meter chips are low-cost, compatible with E3, have high scale, and can monitor 4 rails each. Intel, Microsoft, and Microchip partners to develop a precise power measurement solutions that cost less than $1,000 USD and is capable of monitoring 32 rails. Intel developing the hardware design, BIOS or EC, and samples. Microsoft developed power meter driver and applications for viewing or saving energy data. Microchip developing power meters. There are a total of 8 power meters on this HDK. The solutions enables OEMs and ODMs to plug and play the different components and firmware to measure power and select parts for their BOM that meets their power modeling goal. The real-time power monitor app can be run on the remote measurement PC and displays real-time energy consumption data that can be filtered down by each rail. It also offers the ability to write the energy data to CSV file. The I/O board enables partners to plug and play the different components and measure, access, optimize and validate the power flow of hardware component. The HDK can be connected to a measurement PC, enabling a much richer and detailed power optimization of modern standby devices while they are in connected or disconnected modern standby. The solutions aligns with the Intel Cannon Lake release. Please reach out to your Intel representative to learn more. So let's have a look at the assessment toolkit overview. The assessment toolkit is a component of the assessment and deployment kit. This toolkit contains automated performance and quality assessment and energy efficiency workloads that enable partners to optimize Windows devices during device bring-up. Performance assessment generates metrics such as boot time, app launch time, and memory footprint. Energy efficiency workloads generate battery rundown states. All the assessment and workloads have options to generate robust and actionable ETW logs for analyze in tools such as WPA, Windows Performance Analyzer, and MXA, Media Experience Analyzer. The assessment and workloads can be packaged up or run directly from the Windows Assessment Console. And for Crazy's update, there are new media quality assessment that generates video audio glitch count metrics. We also added a new energy efficiency workload for office productivity and video playback. All the assessments or workloads are supported on x86, MD64, and ARM64. Several out-of-date energy efficiency workloads have been deprecated. If you are interested in evaluating the assessment, please download the ADK and install the Windows Assessment Toolkit as shown in the screenshot here. The early build ADK builds are available to Windows Insider and EAP partners. We encourage you to download and give them a test drive today. Now, in order to install the Assessment Toolkit, please select the Assessment and Performance Toolkit. We also recommend installing Media Experience Analyzer, which is useful for analyzing ETW logs generated by the media quality and media energy efficiency workload. The media quality assessment offers several playback sources, including local and streaming videos in the movie and TV app, and Netflix streaming. The assessment captures ETW logs, which are post-processed to generate audio or video glitch counts, which can be viewed in the Windows Assessment Console. So let's walk through the 3 steps of running the media quality assessment. The first step is to launch the Windows Assessment Console, select Options, then New Job. Second step is to select Create a Custom Job. And lastly, the third step is to click Add Assessment and select the Windows 10 Media Playback Quality Assessment. The Assessment Toolkit offers several energy efficiency workloads, including modern standby, idle, office productivity, and several full-screen video playback. The projected time to shut down and other support energy efficiency metrics can be viewed in the Windows Assessment Console. Let's walk through the 3 steps of running energy efficiency workload. First step is to launch the Windows Assessment Console and select Options, then New Job. The second step is to select Create an Energy Efficiency Job, and lastly, step 3 is to click Add Assessment and select a workload. We encourage you to download and give the new assessment and energy efficiency workload in the Fall Creators Update a test drive today. So with that, this concludes our talk on designing and optimizing for longer battery life and responsive Windows devices. There are many reference slides in the appendix, so please download the slide deck after the event and review these resources. Thank you for your time and enjoy WinHEC.